Hello, everyone. We're taking a look at some of the most iconic material in algebra, the Pythagorean Theorem. We're beginning with the basics today. Let's get started. In order to start off with the Pythagorean Theorem, we need to know what it is. First off, it's based on a formula that's built from right triangles. If a triangle is a right triangle, then you can use the formula a squared plus b squared equals c squared. And that formula always works for right triangles. In order to get the a and b, those are the legs. The shorter sides, a and b, always share the 90-degree corner on one side, and across from that 90-degree corner is the hypotenuse. It represents C in the right triangle, and it's always the longest side. So you can tell where the hypotenuse is just by looking off from the right angle in the triangle. You know that the hypotenuse C is always opposite of that right angle. So I'm sure you're wondering how this formula even works. Well, the idea starts with recognizing that you can use the formula for a right triangle problem. Here we're determining a missing length. And this is where the Pythagorean theorem, at its basic level, is most helpful. See, we can take two side lengths, the A and B, 7 and 6 in this case, and plug them in for A and B. So now I need to know what my 7 squared and my 6 squared are. Well, 7 squared is 7 times 7, or 49, and 6 squared is 36. So now I have 49 plus 36 equals my missing value squared. And I can add 49 and 36, so I will. I'll get 49 plus 36 is 85. And that means that something squared is 85. You know, I would know this if it was 81. Like, if it was 81, then I could do 9 times 9 and get 81. But that's 85, and I don't know what times itself is 85. I think I'm going to need a calculator here. So I can do the square root of 85. Yeah, so square root, meaning that I have to take the square root of both sides. I've got a really long decimal. Oh, fortunately, I can round to the nearest hundredth. So we're going to round. The original value here that I have is 9.219544445. So there's just, this decimal goes on and on and on and on. But I don't have to keep all of it. I can round to the nearest hundredth. So we're going to say approximately equal to hundredth, so 10th, 100th, rounding the 9 up. We can round this to 9.22. That seems perfectly serviceable as an answer to this question. I'm going to put a square around it. Ooh, I should probably put this down to be x, though, since the name of our missing variable was x. There we go. And now we have a complete answer to this problem. Next, we have a problem that looks the same on the outset, but oh, you can't see it. Whoa! Okay, well, now you can see it, right? So I can determine the missing length. You know, this looks the same, but it's not. So here's the deal. The setup's fine. It's still a squared plus b squared equals c squared. But it's what happens after we start plugging numbers in where we start to get something different. See, I don't have... In the last example, we were missing the c value. Here, they gave it to us. They gave us 26 as the c value. So when I plug that in, incidentally, they gave us what was the answer to the last problem, which means this missing value, x, because it's adjacent to a right angle, is actually either a or b. Now, we don't have to, we can just pick one. It doesn't have to be a or b, but as long as it's one of those things, and we plug in the 24 for the other leg, we can solve. So at this point, I've done the first part. I've plugged in everything. Now I have to square and find out the values to solve. So 26 squared, 26 squared is 676. Meanwhile, 24 squared is 576. Yes, I'm using a calculator. I don't have these squared values committed to memory. But now that I have that information, I should know that I have to do 576 plus something equals 676. Well, as a quick step here, I'm going to subtract the 576 from both sides and get 100. Now, x times itself is 100, so what times itself is 100? Well, I can square root both sides. And 10 times 10 is 100, so the answer, x, is 10. Fortunately, that one didn't have any wacky decimals in it, but it did have a subtraction step instead of an adding one. And that's a big deal when we already knew that the hypotenuse was 26. And we've reached the summary page. Oh. Well, I have to go for a ride. Oh. Okay, well, here's the deal. The point of this set of notes is to share with you that, first off, we're dealing with the Pythagorean Theorem. It's centered around a formula, a squared plus b squared equals c squared, used when you have a right triangle. And today we're just starting with the basic steps, substituting what you know into the formula, squaring the values because of the squareds in the formula, solving either by adding, like we had in the first slide, or subtracting, like we had in the second slide, and then in either case, you need the square root. That'll about do it for this set of notes. Keep in mind, though, this is part 1. There's more to come as we get some more ideas of how to use the Pythagorean Theorem in different problems. But that'll about do it for this video today. Have a good one!